Today we're going to be looking at parts of a circle slash central angles, arc measurements, stuff like that. Okay, let's begin. On this circle on the left, we're going to label these pieces. If you look at the letter K, this is the center of our circle. It's in the middle. Your radii are built from it. The length KL line segment is your radius. JL I'm going to come back to that. Give me 1 second. Your diameter is JI as it goes all the way through the circle. Take a moment. I want you to think about the difference between the chord JL and the diameter JI. A chord is when we have 2 points on the circle. Any 2 points you want, and you're connecting a line between the 2 points. Okay? A diameter is whenever you have a chord that passes through the center. Okay? That's important to note. We have a secant, GI, and notice that that is an outside point G with a line that goes through the circle and touches I. Whereas if you look at J to G, it is a tangent because this line is coming from an outside point and it is just going to touch the circle and bounce off. Well, not really bounce, it's just going to graze it, if you will. So a secant is going to pass through the circle. A tangent is going to just touch it at one point and be done. The point of the tangency is where it touches, so point J. Alright, minor and major arcs. A minor arc is going to be less than half the circle. A major arc is going to be greater than half a circle. So if I look at HI, and I'm going to put a circular, like an eyebrow, over HI, meaning arc. So I look at HI, I went less than half the distance between my circle. I want you to notice, though, I could also do this and come all the way back around to I. And if this was the case, this is definitely a major arc. I did more than halfway around the circle. But I can't just say HI or else I'm going to take the minor arc. I'm going to have to say HJ or HL, either one, doesn't matter, but H, and I'm going to use L just because why not? HLI. The way you determine which arc they're talking about, you go in the order it gives you. So if it says from H to I, you take the shortest route possible to get to I. If it says, like I wrote HLI, you have to go from H, then to L, and then back to I. Okay? Okay. Let's look at a semicircle. A semicircle is exactly half the distance around the circle. So if I take a look at my diameter here, if I go halfway around the circle, I'm going to have a semicircle. Okay, I'm writing JI. Now the question I want you to think about, why didn't I put JLI or JHI? Honestly, you could put either one you want, because it can go in either direction, is going to be the exact same measurement. So I am just going to put JI. Okay? Okay. Your central angle is going to be angle JKL. I have 2 points on my circle, and my angle is going to come from the radius. It's going to come from the two pieces, the two radii, and it's the degree there. Okay? Central angle. My inscribed angle is if I take my circle, I'm going to pick J again, but instead of going to K, I'm going to go to I and then to H. This would be an inscribed angle. Instead of meeting at their center, they're going to be meeting on the side of the circle. So angle HIJ. Okay, let's move on to the next portion of angles and measurements. A central angle is an angle with its vertex at the center of the circle and its two sides are the radii. If I look at the circle on the left, angle ABC is the central angle of the circle. Of course, you should know that the sum of every angle in a circle is going to end up being 360 degrees. Excuse me, I'm sorry. Now, we're going to ignore this for now, but later on we're going to talk about radians. So again, I'm writing in pink. You don't have to write this. This can also be 2 pi radians instead of degrees. Just a little thing I'm going to throw a callback to later. Focus on the 360. The measure of the arc formed by the endpoints of a central angle is equal to the degree of the central angle. Well, what does that mean? A lot of words. Actually, it's quite simple. If I want to know the length, or the measurement rather, of arc AC, I want to know the... Why are you not highlighting? I want to know the arc here. My degree of my arc, the measurement of my arc, is just the degree of the central angle. So, angle ABC is equal to the arc, the measure of the arc AC, which is equal to 84 degrees. Okay, measure of the arc ADC. So we're wanting to find the measurement of the major arc rather than the minor arc. So instead of saying 84, we need to find the rest of our angle. If 360 degrees is the total measurement of of the degrees in a circle, and I subtract our angle measurement of 84 degrees, I'm going to get my answer from my measure of the arc ADC. So I'm going to be getting this angle. Okay, so 360 minus 84 is going to give me 276 degrees. Easy enough. I hope you think so. Find each angle and arc measurement. The measure of arc ST. The measure of arc ST is going to be the same thing. Wait a minute. As the angle SQT, which is 122 degrees. The measure of arc RS is equal to, alright, we don't know what the angle SQR is, which is going to be my reference for this. And some of you may jump ahead and say you can figure this out quite quickly, and you are correct. You can figure this out quickly, but I'm not going to be doing it that way. What I do know is a straight line is going to have a total degree measurement of 180 degrees. So if I have 122 of these 180 on the right side, then the angle on the left side, instead of being 122, must simply be 58. So if angle SQR is 58 degrees, measure of my arc, RS, is also going to be 58 degrees. The measure of arc, SRT. This one takes a little bit of thinking about. Still not that hard, but let's look at it. What I'm wanting to find is the measure of this entire arc. I didn't mean to erase my 58 there. Well, I know that my total measure is going to add to 360, and I'm also going to know half a circle is going to measure to 180 degrees. But I don't just want the 180, I want the additional 58 from the arc RS. Therefore, to get the measure of arc, SRT, I'm going to do 180 plus 58. And that is going to give me 238 degrees. Okay, we're ready to move on. I just want to look ahead here for 1 second. I'm thinking I want to do number 5. Yeah, let's do number 5. I see that I have a 90-degree angle, a right angle, for angle PUR. But what I also recognize, well, wait a minute. Therefore, since this is my diameter, I know this also has to be a 90-degree angle. Okay. But I also notice that this line is going to be cutting off part of that 90 degrees. Okay, so the question becomes, how do we find that? How do we find the measure of the angle QUR or PUQ? So how do we find a piece of that 90 degrees? Well, let's take a look at our alternate angle, TUS. If you would notice with me, both TUR and SUQ are diameters, meaning this angle and this angle must be congruent. Therefore, I know this is 19 degrees, and if out of the 90 degrees, 19 is on QUR, PUQ must be the remaining 71 degrees. If I add up all these numbers, so that'd be 71 plus 19. Okay, just a little bit of quick math. That's 90 degrees. I'm going to add the other 90, and then plus the other 19. I'm going to get a grand total here of 199 degrees. out of the total 360 for SUR. So if I do 360 and subtract my 199, I'm going to be getting 100. One second, my brain just farted. That was right, 161. Okay, I'm going to give you just a second to look at this. Because I filled in every inside angle of this circle, finding my arc lengths should not be a challenge. Measure of arc PQ. If I look at my central angle, it's 71. SR, 161. QRT. So I'm going to take out my 90 and 71, so 161. I'm going to get a 199. PSR, I'm going to be taking out the right angle, the 90 degrees, so I'm going to have 270. And finally, I have just PS. That's going to be my 90 plus my 19, or 109. Okay, I'm going to let y'all do these problems 2, 3, and 4 for practice. So I encourage you to pause it and try those. And I'm not going to talk about them. I will show you the answers though, since I want you to try it and then you can check your work that away. So for number 2, I'm just going to write it. I'm not going to talk so I can waste a little bit less time. Apologies if you have to pause this to go back and check what I wrote. Well, that's talented. I wrote number 2 for number 3. And if you paused it there and wrote it down and now see me rewrite it, once again, my apologies. But knowing most of you, you're skipping through this anyway, so I don't feel too bad. Alright. Now we're getting to the funner stuff, in my opinion. Find the value or measure for each of these circles. So in this one, I'm wanting to find the value of x. So if I have arc RS and I have arc ST, I know that I can sum these arcs because they are on a diameter to 180, being 15x minus 26 plus 26 is equal to 180. 15x equals 180. X dividing is equal to 12. Okay. I'm going to encourage you to try number 7. So pause it now, work on it, and now I'm going to give you the answer. I'm going to skip number 8 and 9 and let y'all work on those to try them out. And I'm going to do number 10. Okay, length of x. If I take my 8x from the top, add my 21x minus 12, my 10x plus 9, I know I'm going to add up to 270. Now, instead of me just telling you why I'm doing that, take a moment and look to see if you know. See if you can recognize what I'm doing here. Alright, now I'm going to tell you. Look here, I know this degree is 90. If 90 degrees is on my angle VZY, or arc VY, whichever you prefer, the rest of this has to be 270. That's why I'm doing the math equation like so. Okay, I want to take this moment just to remind you, if you type this in Desmos, instead of equals 270, put a minus in parentheses around the 270, so the right side, you will get your answer of x equals 7, but now let's do it the algebraic way. If I combine my 8x, 21x, 10x, I get 39x. If I combine my negative 12 and my positive 9, I get minus 3. It's equal to 270. Therefore, 39x is going to be equal to 273. Therefore, x is equal to 7. But wait, this problem isn't done. It wants to know the answers of measure of arc wx, yw, yx, and lastly vxw. Well, I'm going to plug in 7 for x. If I plug in 7 for 8 times x, so this is going to be vw, I'm going to get 56 degrees. I'm going to write in pink what I'm actually doing, and black is my answer. Okay, so 21 times 7 minus 12 is going to give me 135. I'll check that here and make sure it's right. 10 times 7 plus 9 is 79. And yes, my math did end up correct. Okay. Measure of wx, 135. Y to w. Okay, it's going to always take your shortest path possible. So I'm going to be going along this path. Okay, 90 plus 56, 146. Yx, 79. Vxw. After I find v, I'll tell you the, okay, v to x to w. So I'm just not wanting the 56. So 360 minus 56 is 304 degrees. Okay, we're done. I'm going to write down the answers for the rest of them so that way you can check your work when you're finished. But I hope you understand this. If you don't, make sure you ask questions. I'm going to write these down, and then I'm going to say, have a great rest of your day, and be done. Briefly, I do want to mention, notice whenever I'm writing my x equals, that number is a number, not a degree. I don't put 17 degrees, I put just 17, whereas the measure of the arc or the angle measurement is going to be a degree. Anyway. All right, that's it. Have a great rest of your day.